Solving another LeetCode problem. It is marked as hard. Question is profitable schemes. You can pause the video and go through the question first. Okay. Now since you have gone through the question, now let's try to solve it. So problem says that we have n is 5 and n represent the number of people. Minimum profit we have to make at least is 3. Okay. Group represent the activity, the number of people involved in the activity. Here 2, again 2. Now profit, like the profit that we will be getting after performing the activity. Here activity is a crime, so I don't know who has written this problem like this. Okay. So uh, what the problem says is that we have to perform these crimes and we have to generate at least this much profit, and the maximum number of person that we can take are also provided as n value. So if you have gone through this problem, and if you are able to understand, then I think if you have gone through multiple of these questions, you will be able to understand that either we can take this activity. According to activity, I mean you can take this profit or you cannot take this profit. And once you start talking about take and not take, you are pretty much sure that it is going to be a dynamic programming problem. So we can directly understand that okay, this is a dynamic programming problem. And here as well, let's first check this example and understand the number of ways and how it is happening. So here we have provided that maximum n, that maximum people we can be taking for the activity can be 5, and the minimum profit that we should be making should be 3 at least. Okay, so if we take this group, so this much profit will happen, test 2. Okay, it is still not, we are still not reached the minimum profit, so we can take another profit activity, which now we have profit as 5. So is the minimum profit reached? Yes. And have we exceeded the people? No, we have not exceeded the people, so this can be one way. Okay, now let's see what else we could have done. Okay, another way we could have done is that we could have not taken this first activity itself and we could have directly jumped to the second activity. If we could have directly jumped to the second activity, that group size would have been 2, and still I think this will be working because 5 is greater than 2. This is correct. Minimum profit we have made till 3. This is also correct. So one way was this, and the before, then the previous way. So 1 plus 1, 2 ways. Similarly, you can have this. Here also they have provided to make a profit of at least 5, and group can only be of size 10, maximum of 10. So we can take the possible schemes they have provided. It is a classic 0 1 knapsack, you can say, or take or not take conditions that we have to write. One thing that I'll tell you, that what I missed in this writing the solution, I'll let you know. Okay, so we can have a function. Our start will start from the starting index, which is 0. We will be considering the minimum profit. I'll be saying not minimum profit, I'll be saying it as remaining profit to be made. Now what will be n? Remaining people that we can take. Also then I'm passing group and profit. For now, just don't see this dp part. I'll be explaining this dp part soon. Okay, so okay, this also you can skip for now, and the base condition as well you can skip for now. Let's just dive into what we can do and what we cannot do. So what we can do, we can either take this or we cannot take this part. Okay, let's say we do not take this part, so we move to the next part. If we move to the next part, if we move to the next part okay if we move to the next part, we directly increase our index. Remaining profit remains same because we didn't take anything. Remaining people also same, remain same, and remaining things, that group and profit, we are passing. Let's say what happens if we take okay, one important thing while taking is that when we can take, we can only take when we have the number of people. If we do not have the number of people, then how we will take? So if the current activity requires less people, less or equal to people of the remaining people that we have, then only we can perform that activity. So remaining people should always be greater than equal to the current number of people that at the index we are. So takes will be index plus 1. We are considering we have taken also. Now if we have taken, what is the remaining profit? What is the remaining profit? Remaining profit minus what was the current profit. Okay, just ignore this. I'll let you know why I have taken this max of 0. I'll let you know. Okay, now what will be the remaining people? Remaining people minus group number of people and other things. Okay, and since we know that we have to find number of ways, so either we can take and not take, so we'll just add take plus not take. Okay, now let's talk about what will be our base case. What will be our base case? Our base case will be, once we have reached at the end, what will be at the end? After the group has finished, after the profit has finished. So if index is equal to group dot size, we are at the end. At the end, index group dot size minus will one will be the last index, and group dot size will be after the last index. That is, we are at the end. Now if the remaining profit, if we still have some profit to be made, if it is like this, if the profit is still to be made, so that means our choices were not correct and we should be returning 0. Otherwise, if the profits are 0, or either it can be negative, then we say that okay, we have made our work and we can return 1. That is, it is correct choices. Now now uh, here you have seen that I have written max of 0 or remaining profit minus profit of index. Why I have written this? I have written this because of a dp vector. Let's suppose I have not written this. This can go negative, which is true as well. This can go negative. Remaining profit is negative. That means we are making more money. We are making more profits, which should be allowed as well. But since we have to store dp states and we are storing states in form of indexes, we can't have negative indexes. That is why what I have done, either max of 0 you can take, or max of the remaining profit we can take. That will be representing our state. Only this part I think you should keep in mind. Okay, so whenever you are reducing some values, then you should always keep in mind that you are not going in the negative part. Okay, but you will ask that what happens in remaining people. See, in remaining people, always we are checking that remaining people is greater than equal to the group of index. Then only we are moving to the take part. Okay, now how we have initialized the dp. So initialization of dp, we have three. Just a second. Yes, initialization of dp vector. How we are doing is that we have three changing parameters. One is the index itself, another is the profits, and another is the remaining people. So we will have 3D vector, which is dp. So for I have taken out the indexes. How many indexes will be there? I'm naming it I and ds. So I and ds. Another one will be minimum profits, which is directly provided, and last one will be the number of n will be the number of maximum number of people that we can take. So I've directly passed. This is the very classic approach of putting all states as -1 until they are reached, and if they are reached at once, we can directly return, and also keeping storing all the answers here directly we can do it. So this is the normal approach that we are taking. And let's talk about time and space complexity. So here you can see we are using a 3D vector. So we how many states we are having, we how many what is the size, we can discuss. The size will be group dot size times profits times the number of people n provided. Okay, this is our size. And also, since we are still having recursion inside, so we are calling inside, so there will be stack space as well. Okay, now let's talk about the time complexity. Time complexity, since all these states will be visited only once, because we do have a check here, so order of the size of the dp vector will be our will be our time complexity. So that I'll run this as well. I've already run this. Okay, so this gets submitted. When you see these kinds of problem, like we have two or three, more than two, three parameters changing, you can do a memoization. I think this much it should be fine for an interview. Thank you guys. See you in the next video.